All right, IM3 classes. Today we're talking about special right triangles. There are two types of special right triangles. There are 45, 45, 90 triangles, and there are 30, 60, 90 triangles. These are going to become very important later on when we get into something that's called the unit circle. That's when we get a little bit further into trig. So it's important that we review these things now that we have a good understanding and handle on special right triangles. So starting off with 45, 45, 90 triangles, here I was going to show you some patterns. I'm just going to get into it this lesson. There's a shortcut for 45, 45, 90 triangles. If you know the two legs of a right triangle, you can find the hypotenuse by multiplying the leg by the square root of 2. If you know the hypotenuse, you can find the leg by dividing by the square root of 2. So before we would need to use Pythagorean theorem to find missing side length, but if you have a right triangle where two of the angles are 45 degrees, all right, you can use this shortcut. All right, so this is also would be an isosceles right triangle, because not only are the two angles, the non-right angles, those would be the base angles, not only are they congruent, the same, the side lengths are the same. All right, so it's gonna be x and x. If you know a leg, multiply by square root of 2. If you don't know leg, or if you know the hypotenuse, to find the leg, you divide by square root of 2. I have this handy flow chart. I'm going to see about getting this posted to Google Classroom. So if you want to use it, you can put it in Google Classroom. But basically, it's just for 45, 45, 90 triangle. What side do you know? If you know a leg, find the hypotenuse, multiply the leg by square root of 2. If you know the hypotenuse, to find the leg, you divide the hypotenuse by square root of 2. So let's look at some examples. Find the length of the hypotenuse. So real simple. This is 45, 45, 90 triangle. This side is also 8 because the sides are the same. To find the hypotenuse, you multiply the leg by the square root of 2. And this, it's as easy as just slapping the square root of 2 onto the side length. Easy. This one, a little bit tougher. Actually, not even that much tougher. So the leg length is 8 square root of 2. We're going to multiply that times the square root of 2. All right, so remember we can, since the square root of 2 and the square root of 2 here, they're underneath the same radical, we can actually multiply those together. So root 2 times root 2 is root 4. And then root 4 is 2. So the square root of 4 is 2. So 8 times 2 is 16. So there's a little bit of multiplication you have to do with that one, with problems like that. So just be aware and simplify fully. We can't leave it down as 8 times the square root of 4. We know what the square root of 4 is, and we can multiply that all the way out. All right. Find the lengths of the legs of the triangles. So this is pretty easy. At least for this one. So I'm going to take this value and I'm going to find that side by dividing by the square root of 2. So I'm going to take that, the length of the hypotenuse, 5 times the square root of 2, and I'm going to divide it by the square root of 2. Here's a nice thing, square root of 2 on the top and bottom cancel each other out. And so I just have 5. So the x's are 5. Here, so again, I'm going to take this and I'm going to divide it by the square root of 2. All right, so 3 divided by the square root of 2. Can't leave it like this. We need to rationalize the denominator like we did in the last unit. So what I'm going to do is multiply top and bottom by the square root of 2. All right, square root of 2 times square root of 2. Remember, square roots cancel each other out. That's just 2 on bottom. And then 3 times square root of 2, just squish those together on top. So 3 square root of 2 is the length of the x. All right, so when you're dividing by the square root of 2, you may have to rationalize the denominator. And that will do it for 45, 45, 90 triangles. On the next video, we'll talk about 30, 60, 90 triangles. Exciting stuff.